Welcome, everyone. Today we are bridging the gap between human language and database language. We'll demystify SQL querying, break down complex join statements into plain English, and learn how to leverage Claude as your ultimate database assistant. Let's get started. Let's kick things off by defining our core toolkit. SQL, or Structured Query Language, is the undisputed language of data. It's how we talk to databases. The beauty of SQL is that it is declarative. You simply describe the data you want, and the database engine figures out the fastest way to get it. Why is this so crucial? Because raw data is useless until you query it to find actionable insights. Traditionally, learning SQL meant memorizing complex syntax and execution orders. But today, we are introducing a paradigm shift: AI-assisted querying. By leveraging Claude, you no longer have to struggle with missing commas or forgotten keywords. You describe the business problem like, find our top 10 customers by revenue last month, and Claude translates your plain English intent into robust, optimized SQL. It's like having a senior database administrator sitting right next to you. Take a look at this high-level workflow. On the left, we start with your plain English intent. This feeds directly into Claude. Claude acts as a translation engine, converting your natural language into strict, optimized SQL syntax. That query is then executed against your relational database, yielding the final actionable insights. We are bridging the gap between human thought and machine execution. Before we get into complex relationships, we must master the anatomy of a basic query. Every SQL query is built on a simple foundation: select, from, and where. Think of select as telling the database what columns of data you want to see. From tells it where that data lives. And where is your filter, establishing the rules for which rows to include. Why do we filter? Because querying a billion-row table without a where clause will crash your app and rack up massive cloud bills. Here is where Claude shines. When you ask Claude to write a query, it doesn't just blindly write the code. It applies reasoning. If you ask for active users, Claude's underlying logic engine might suggest adding filters for deleted accounts or inactive logins, catching data edge cases before they skew your reports. This diagram illustrates the logical order of operations when constructing a query. We start at the top by selecting our columns, move to defining our source table, and then apply our row-level filters with the where clause. From there, we can optionally aggregate data with group by, and finally sort our output using order by. Understanding this flow is essential before we start linking multiple tables together. Now we arrive at the core of relational databases: the join statement. What exactly is a join? In plain English, a join is simply a way to stitch data from two different tables together based on a common thread. If you're coming from Excel, think of it as a VLOOKUP on steroids. Why do we need this? Because modern databases use a concept called normalization. We don't store a user's home address on every single order they place. That would waste space and cause update anomalies. Instead, we store the user in a users table and their orders in an orders table. We use a unique IDA key to link them. When working with Claude, you don't have to remember the exact syntax of the keys. You can simply tell Claude, link my user profiles to their transaction history, and if Claude has your schema, it handles the complex stitching automatically. Look at this visual representation of a join. We have the users table on the top left and the orders table on the bottom left. The magic happens in the middle node, the join operation. It acts as a bridge, finding where the user ID matches the customer ID. The output on the right is a beautifully combined result set featuring columns from both tables, like the user's name right next to their order amount. Let's deep dive into the two most critical types of joins: inner join and left join. An inner join is strict. It's like an exclusive club. It only returns a row if there is a perfect match in both tables. If a user hasn't placed an order, an inner join drops them from the report completely. A left join is more forgiving. It says, give me every single user from my left table, regardless of whether they have an order. If they don't have an order, just leave the order amount blank or null. This distinction is vital. If your boss asks for a list of registered users who have never bought anything, an inner join will give you 0 results. You must use a left join and filter for the nulls. When you prompt Claude, simply explain your business goal. Claude's logical reasoning will automatically select the correct join type to prevent your data from being skewed. This split diagram perfectly illustrates the behavior difference. In the inner join path on the left, user 2 has no order, so they hit the dropped node and disappear from your data. In the left join path on the right, user 2 is preserved. They pass through to the final result set, but their order details are simply marked as null. Understanding this diagram prevents 90% of common SQL errors. Let's talk about prompt engineering for complex SQL. As we get into advanced territory like subqueries, window functions, and multi-table joins, you cannot just ask Claude a vague question and expect perfect code. You must provide context. The best practice is to export your database schema, your table structures, column names, and keys, and feed it directly into Claude's context window. To do this cleanly, wrap your schema inside XML tags, like database schema. This explicitly separates the database rules from your plain English instructions. And here is a massive deep dive tip for professionals. If you have a massive enterprise schema, use Claude's prompt caching. By putting that large schema at the very top of your prompt, Claude caches it. Every subsequent follow-up question you ask about your data will execute incredibly fast and cost up to 90% less. Observe this sequence diagram. The analyst starts by uploading the raw database schema inside XML tags, followed by the plain English business query. Claude intercepts this payload, caches the schema context for efficiency, and internally maps out the foreign keys and optimal join paths. Finally, it outputs highly optimized, schema-accurate SQL. This is the blueprint for zero hallucination code generation. Writing the SQL is only half the battle. Once you run that perfect join query, you get a massive table of raw data back. What's next? With Claude's advanced capabilities, we go beyond writing SQL into actual data science. You can export your SQL results as a CSV file and upload it directly back to Claude. Using its built-in code execution tool, Claude acts as your personal data scientist. You can say, analyze the CSV using Python to find anomalies in purchase behavior. Claude spins up a secure, sandboxed Python environment behind the scenes. It reads your data using libraries like pandas, performs complex statistical analysis, and can even generate beautiful charts and graphs. You've seamlessly moved from raw data extraction to executive-level visual insights, all without leaving the chat interface. Follow the data pipeline in this diagram. The optimized SQL hits the database, which kicks out a CSV file. That CSV is fed into the Claude Code execution node, our computational sandbox. Inside that sandbox, Claude writes and executes Python code, splitting the output into deep statistical analysis and beautiful visual charts. It is an end-to-end data processing pipeline. Here is where this technology becomes truly groundbreaking. We've talked about copying schemas and uploading CSVs, but what if Claude could just talk to your database directly? Enter the Model Context Protocol, or MCP. MCP is an open-source standard that acts as a secure bridge. You can connect Claude Code directly to your live PostgreSQL, MySQL, or Snowflake databases using a simple CLI command. Why is this revolutionary? Because it makes Claude an autonomous agent. If you ask, why did revenue drop yesterday? Claude will autonomously query the live database schema, figure out the required joins, execute the SQL against the live data, and synthesize the results for you in real time. It completely eliminates the manual friction of data analysis. This architecture diagram is the holy grail of modern querying. The analyst speaks plain English to Claude Code. Claude Code doesn't just generate text, it communicates securely over the Model Context Protocol, MCP, to a localized gateway server. That gateway securely executes the SQL against your live production database and returns the results to Claude. It is a live, breathing, autonomous data loop. As we wrap up our deep dive into SQL, joins, and Claude, we must discuss the most critical topic for senior engineers: security and guardrails. If you connect an AI to your database, rule number 1 is absolute. Always use read-only credentials. Never give an AI agent the ability to drop tables or delete data in production. Rule number 2, mask PI. Ensure your database views prevent sensitive data like SSNs from reaching the AI context. Finally, adopt the trust but verify mindset. Always ask Claude to show you the SQL it wrote before it executes, ensuring the join logic is sound and no Cartesian explosions will occur. You now possess the blueprint to merge human intent with complex database logic. If you found this deep dive valuable, I invite you to like this video, subscribe to our channel, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you for learning with us. Our final diagram is a security decision tree. Every AI query request must pass through a strict gate. Is it a read-only user? If not, execution is instantly blocked. If yes, it checks for PI. If sensitive data is detected, it is masked before proceeding. Only after passing these rigorous security checks does the system execute the SQL and return your insights safely.